Hi, third graders. This is Miss Coleman, and today is Tuesday, and we are going to be working in our iReady instruction book, and we are working blue pages, and it is page. We're actually going to do 4 pages today, so it's 310, 311, 312, and 313. So I'm having to record my video at home. So I'm going to put it on this chart paper for you. So make sure you're paying close attention and following along in your blue iReady book. So let's look at page 310 right now. So on 310 at the top, you've got Emma, and she has drawn a rectangle at the right. And inside her rectangle are some little squares, okay? And then it asks, what other rectangles have the same area but a different perimeter? So we're going to be looking at shapes that have the same area but have different perimeters. And you can see 2 examples of that. Now remember area, let's remind ourselves real quick. Area is going to be where we do length times width. And perimeter, we're going to add all sides. Okay, so there is a difference between how we do area and perimeter. All right, let's go on and across and work some of these problems. Let's look at page 311. It says, look at, picture it, okay? How can you tell the 2 rectangles shown have the same area as Emma's rectangle? So again, for area, so if we look at your book, your original shape was a square that had 4 rows and 4 columns. So it looked like this. So to know what your area is, let's go ahead and do area. We would simply either do length times width, or we would count our squares. Since it is a square, it is 4 rows and 4 columns, which gives us an area of 16. And then for perimeter, we would have to go all the way around. So that would be 4 plus 4 plus 4 plus 4, because you have 4 lines on every side. 4 plus 4 is 8. 4 plus 4 is 8, and 8 plus 8 is 16. So this is an example where you have the same area and the same perimeter. That doesn't always happen. That's pretty rare. So now we're going to look at the 2 picture-its. So the first one is 1 row that goes all the way across. And how many squares, how many columns or squares are in that row? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we still have 16 as our area. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Pretend those are equally spaced. So we still have an area of 16, because 1 times 16 would be 16. What would be my perimeter? 1 plus 16 plus 1 plus 16. Remember perimeter, we got to walk all the way around. So 1 and 16 is 17, plus another 17, and 17 plus 17 is 34. So these did not match. So the question was, how can you tell the 2 rectangles shown below have the same area? Well, this one we know has the same area because it is made out of 16 squares. Let's look at that second one that they drew, which is 2 rows and 1, 2, 3, 4, 5, 6, 7, 8 columns. 1, 2, 3, 4, 5, 6, 7, 8 columns. So that area would be 2 times 8, which we know is also 16. What would the perimeter of this one be? Let's figure that out. So we have 2 plus 8 plus 2 plus 8. 2 and 8 make 10. 10 and 10 make 20. So this one would have an area of 16, and a perimeter of 20 when we walk around and add all our sides. The question is not asking about perimeter though, third graders. It's saying, how do you know that they have the same area? Well, we can do two things. We can either count all our squares inside our shape, or we can multiply the length times width. So for your answer for number 9, in this number 9, yes, for number 9, how do we know they have the same area? They all have 16 squares inside the rectangle. Because that's how we find area. We count the squares on the inside of the shape. So once again, number 9, they all have 16 squares inside the rectangle. All right, let's look at number 10. Number 10 says to find other rectangles with an area of 16 squares, think of multiplication facts with a product of 16. What are the multiplication facts that have a product of 16? So we want all of our answers to equal 16. We've just got to come up with problems that will give us the answer 16. So let's start with our 0 facts. Can I get 16 using 0? No. All right, let's go to our 1 facts. Can I get a 16 using a 1? Yes. 1 times 16 is 16, or 16 times 1 is 16. So we could draw a 1 by 16 rectangle like this one, or we could turn it and stack it going this way, couldn't we? And have 16 by 1. All right, let's go to our next fact. What about 2's? Is there anything times 2 that will give us 16? Yes. What is it? 2 times 8 is 16, or we can do commutative property and say 8 times 2 is 16, can't we? So we could have 2 rows of 8, or we could flip this one up and have 8 rows of 2. Remember those arrays you've been practicing for homework? That can help us. Is there any other multiplication fact that you can think of that will also equal 16? Yeah, 4 times 4. Now, if I use the commutative property on that one, what's going to happen? It's going to be the same thing. So we actually have 1, 2, 3, 4, 5 rectangles we could draw that would all have an area of 16, because every one of those would need 16 squares in order to fill in that shape. All right, let's go to still number 10. This is the first part. There's a second sentence. It says, look at the table and model it. Where do you see the factors and products of the multiplications you wrote? Where are the factors? The factors are on your length and width. And where are your products? Your area would be your product. Your perimeter is not a product, because how do we find perimeter? By adding. So that would be a sum. Product means the answer to multiplication. So our second part of number 10 is we're going to say the factors are length and width, W-I-D-T-H. The factors are length and width, and the product is the, and I'm going to squeeze this in, area, A-R-E-A, period. Factors are your length and width, because remember in area we're doing length times width. So the factors are length and width, and the product is your area. To get the area, we have to multiply. 1 length times your width. So factors, length and width. And area is your product. You could also say that your factors are your rows and columns, couldn't you? If you're drawing your picture, it's just like an array or an area model. That's why it's called an area model, because you're filling in with squares, so that makes your area. All right, number 11, and I'm going to take this chart off. I'm going to leave it up though, in case we need to go back to it. So this is number 11. Still talking about perimeter and area. It says, can 2 rectangles have the same area but different perimeters? How do you know? Well, let's go back. I should have left this up, shouldn't I? Did we not have the same area on all 3 of these? Area 16, area 16, area 16. But was our perimeter the same? Perimeter 16, perimeter 34, perimeter 20. Are those the same? No. So the question again, can 2 rectangles have the same area but have different perimeters? Can they? Absolutely they can. Yes. Yes, that you can have the same area but have different perimeters. Rectangles can have different side lengths to multiply but make the same area. But they would add up to get the perimeter. So let's say the lengths can add up to get a different perimeter. The lengths, L-E-N-G-T-H-S. The lengths can add up to get a different perimeter. All right, 12 and 13, I'm going to let you work those. So it says, use what you just learned about area and perimeter to solve the problems. Look at the rectangle below. Draw a rectangle that has the same area but different side lengths. So first you've got to figure out what that particular rectangle has. What would your area be? You can count your squares or do length times width. And then come up with some more rectangles that would have that same area. That is just like what we did right here when we did our 1 times 16, 2 times 8, 8 times 2. We came up with all the ways we can get that same area. What are 2 factors that we could multiply to get that area? Okay. And then number 13, look at the rectangle you drew for problem 12. Would its perimeter be the same, greater than, or less than the perimeter there? So then you're going to have to go back and find your perimeter of their rectangle and your rectangle. So remember, for perimeter, we got to walk around our shape and add up all our sides. All right, so that's page 310, 311. Go ahead and tear out your red pages, which is going to be 325 and 326. You will be looking at area and perimeter because now we're putting them all together on the same rectangle.